So what we did in our last class, we ended our discussion on proving some identities about sets actually. Okay, some identities about sets. Right. This was the first thing that we have done. Now, what I would like to do, I mean, you can also see the the chapter exercise 5.1 actually. I mean, if you wish, you can have a look on the exercise 5.1. Okay, the section, the questions corresponding to the exercise 5.1. You can already do all of them actually, except some about the partition. So it's better that I should talk about the partitions first, and then and then a little bit about the power sets, and then you know, uh, then move to the next topic actually. So what do we mean by a partition actually? So let's start with partitioning a set. Okay. So what is the natural idea of partitioning? It's a very natural idea. So imagine you have been given a place or a room or a home or something like that, and you want to partition it actually. So how are you going to partition it? What do you think? What should be the most natural way to partition things? So if I give you an object, how are you going to partition? What should be the meaning of partition? Anyone?
Parts.
So one thing is that, okay, making the parts is the obviously an important thing. That okay, if you have been given a place or a set or an object and you want to partition it, making a part is an important thing. But making only part is not enough actually. You have to make the parts that do not overlap with each other actually. Okay, because if if there is, for example, a part which is kind of shared between the both, then I can't say that like this is true partitioning. Okay, because you are still sharing you know a part actually. So by partitioning we mean splitting a set or a given object into kind of a parts where nothing is shared actually. Okay, nothing is shared. So like this region 1 and 2 and 3 and 4 and 5, all these regions have nothing in common actually, right? So you're going to call these parts as a partition. Okay, so this would be the really the partition. Okay, so now if I say you to make this notion more formal, how can I make it a formal set actually? So for example, let's start with a very simple example. So imagine you have a universal set. Okay, so say for example, this is my universal set. Okay, so what should be the meaning of partitioning a universal set? So for example, if I draw a set here, say, let me draw a set here, A, then can someone tell me that I have already partitioned, I've already partitioned the set section? ये ले लो ना, ले लो, ये ले लो, ये ले लो, ये पड़ा है. देख लो ये वाली है, वो दूसरी ये इसके नीचे पड़ी है टेबल, ये ले लो। नहीं नहीं, इसी के नीचे पड़ी है ना मेरे बच्चे, ये इसमें लगी हुई है ना मेरे बच्चे। ठीक है, ओके जी। So can someone tell me that if I am drawing a set in a universal set, then how I am partitioning the universal set? Can you tell me the two parts of the universal sets?
Sir,
Sir,
A
A
and
or
A
A
complement.
complement.
Yes, so you have the two parts. So one part is A and the other part is really A complement actually. Okay, and I know that A complement and A are the two parts, okay, which do not uh, intersect with each other. They are the two separate parts actually. So I can say that this A and A complement, they partition partition U, because if you put the both parts together, you're gonna get the entire set U, and there is nothing common in both. Okay, there is nothing common in both. So these are the, like, this is really the intuition of the partition, that okay, split a set into the parts. If you put them together, if you union them, you should get the whole thing, and there should not be anything common in the both parts actually, right? So let me write a formal definition. Let me write a formal definition. So here's a definition of where is it? So we say that, a set, so here's a definition. A set, say X, okay, is partitioned, okay, in parts which have a technical name actually, which are called cells, okay, partitioned in cells, okay. Let's give these cells a name actually. Okay, so I don't know, let's call it A, B, C, D, some sets actually. Okay, not necessarily 3 or 2 or 4, they can be anything. Okay, right? The parts. If, so we're gonna say that like this is a partition of X, if what happens, that if you take the union of these sets, A union B union C union D, and so on and so forth, you should get the entire X. And if you see the intersection, disjoint intersection, A intersection B, and say B intersection C, or A intersection C, all possible pairs, okay, all possible pairs that you can make out, they all are disjoint. They all are disjoint actually. Okay, so we're going to say this is really the partition of the given set X. So have you got the idea that what do we mean by a partition? It's like splitting into a set into the parts. If um, splitting into the parts, who, when you put them together, when you union them, you get entire X and their intersection is empty. Okay. By the way, the book also write this definition in a very interesting way actually. Okay, in a very interesting way. So here's the way. So it says that imagine you have a set A. Okay, so let X, say for example, be a set, and let P be a collection collection of subsets of X. All right. So there are some subsets, not all necessarily, some subsets of X actually. All right. Then we're gonna say that this set P is a partition. Okay, it's a partition of set X if the two conditions are satisfied. Okay. Every element A in X, okay, for every element A in X, there is a subset of X in P. Let's call it, I don't know, let's call it S, all right, in P such that A belongs to P, okay? Uh, so who can tell me the intuition for the first statement actually? And if I give you two sets, say S and T from the set P, then S intersection T is empty, okay? Provided that S and T are two different sets actually, okay? S and T are two different sets. So can someone tell me that how this definition is basically same as this definition, that is split a set into some disjoint parts, okay? So what does the first statement is telling you? First statement is telling you that every element of X is in some set in P actually, okay? So there is a part in the partition, okay, that contains your, that contains your required element actually, or element A, okay? So every element of A is in some part of X actually, okay? And that part must be present in P, okay? For example, let me give you an example actually. So let me show this through an example. That imagine I have a simple set, say 1, 2, 3, and 4. Can I say that which of these is a partition? 1, 2, 3, 4, okay? And say there is another, for example, potential partition. I'm writing 1 and 2 and 3, 4, for example. And maybe a partition claimed is, I don't know, 2, 3, and 4, so on and so forth. So can you say that why this is a partition? This is a partition because every element of A, or maybe X, let's give it a name X because we have used X here. Every element of X is present in some set in partition. So do you agree with me?
Yes, sir.
Every element in A is present in some part of what do you call the partition? Some sets in partition. And is there anything common? So that's what the first condition is saying, that every element of A must be, sorry, this should not be P, this should be S actually. This should be S. For every element, we can find a set in the partition which contains that element A actually. Okay? Which contains that element A. So is 3 is in some part of the partition? The answer is yes, actually, that it's in this set. Okay. Is 4 in some part? It's in the same set. Is this, and obviously the second condition that you have to verify is that that all sets within a partition, okay, all sets within a partition must be disjoint actually. So there are two sets and both are disjoint from each other. So we're going to say this is a partition of the set X, right? Is this a partition of the set X? So the first we have to see that, okay, pick any element from the set X, it must be present in some set in the partition actually, right? So for example, if I pick say 3, so if 3 is present in some set here, the answer is yes actually, it's present here. Is 2 is present some in some set here? That's it. Yes, it is present in say singleton 2 actually. So we can see that all elements of X are present in some set in the set partition. Okay, and and what? And and what? And if you compute the intersection of any two sets, so that's empty. Okay, so this is also a partition. Is this set a partition?
No, sir.
This is not a partition. Okay, 2 is here in this set, 3 is here in this set, and 4 is here in this set. But the first condition requires that every A in X must be present in a set in P. Okay, you know, every A, you can find a set in P, the partition, supposed partition, which contains that element A. So you have 1 here. Is this 1 present in any set here? So you're going to say that this is not a partition actually. I can also write, for example, that, okay, 1 and 1, 2 and 3, 4. Is this a partition? Can I say this is a partition?
No, sir.
You still can't say that it's a partition. Why?
No, sir.
Sir, 1 is in both sets, sir.
Yes. So all elements, so it satisfies the condition 1 actually, that the all elements of set X are in the sum set in the partition. But like these two sets, like, okay, given two sets from the partition, if they are different, okay, if they are different, then their intersection must be empty. Okay, the intersection of this and this is empty, but the intersection of this and this is not empty. So therefore, you're going to say that this is also not a partition. Okay, this is also not a partition. So in a simple language, partitioning means splitting a set into such kind of parts, all right? Splitting a set into such kind of parts that that if you put those parts together, okay, if you put those parts together, you get the entire set, and the parts do not intersect with each other. They don't intersect with each other. So this is what really the definition of the partition is. All right, let me give you another example, an interesting one. Imagine you take, say, a Z, okay, which is the set of integers 0 and plus minus 1 and plus minus 2 and so on and so forth. Okay, 0 plus minus 1. And I'm asking the question, is following sets are making a partition? So if, for example, P contains 3 sets, say S0 and S1 and say S2, where S0 is what? S0 contains the integers, okay, but the integers of this form, n equal to 3k, and S1 contains, obviously k is also an integer, uh, it contains integer such that n equal to 3k plus 1, okay, where k is an integer and s2 is n belongs to z such that n equal to 3k plus 2, okay, where the k is in z. So can I say that these three sets partition z, okay? You know, I can't see it at the moment from their description actually at the moment, okay? By the way, what does the set S naught tells you? What is S naught? If I write it explicitly in the terms of elements, what is X naught? So
Sir,
X
3.
naught X naught contains all those elements which are multiple of 3. So, you know, obviously 3 is going to come, 3 is a multiple of 3, and minus 3 is also a multiple of 3. So plus minus 3, plus minus 6, plus minus 9, and so on and so forth, they all are going to come inside the set S naught. But not only 3, but 0 is also going to come because 0 is also a multiple of 3. How about S1? By the way, what does this description is telling you? What is the meaning of n being 3k plus 1? I know that what is the meaning of, you know, 3k, okay? So it's like it's a multiple of 3. It's a number that is divisible by 3, but plus 1. So what does the plus 1 is telling you? Anyone?
Sir, even numbers?
This is telling you, obviously these are going to be, no, whether they are even or odd, whatever, doesn't matter. It is going to it is telling you that when you divide n by 3, okay, there is a remainder 1 actually.
Yes.
There is a remainder 1. You can't completely divide this n by 3. There will be a remainder. So plus 1 is like the remainder. So what does S1 is telling you, that what are those integers when you divide them by 3, the remainder would be 1. So which are those integers actually? Anyone?
4,
Okay, so
4, 7,
not only 4, but plus minus 4,
4, plus minus 4, plus minus 7,
plus minus 7,
plus minus 10,
plus minus 10, and so on and so forth.
so on.
But here's the interesting thing. Plus minus 1, 1 is also going to come, not plus minus 1, the 1 is also going to come actually. Okay, 1 is also going to come in this set. Can someone tell me why the 1 is going to come in this set?
Sir, 3 is a multiple of, sir, 0 is a multiple of 3, and when we add 1,
Yes.
it will be, sir, 1.
Yes, yes. So since 1 can be written as 3 times of 0 plus 1, so therefore, you know, 1 is in this set. So how about S2 now? What is S2? So you can say, can someone tell me what is
S2
what does
S2
this?
सर S2 वो सेट है जो
किसी नंबर को 3
S2 is a set when we
divide by
जब
Exactly. So when you divide any number by 3, then you know you get a remainder. What do you call? 2 actually. So which are those elements which are divisible by 3 and have
सर ये
remainder 2?
-4 कैसे आया सर ऊपर वाले में?
-4 नहीं आएगा, बिल्कुल नहीं आएगा. -4 नहीं आएगा. Yes, you are right. There will be no -4. So you have to be careful. You have to say it carefully. Let me list these carefully and correctly. Okay. Let me rewrite this S1 again. That, okay, it is going to, let's just start with say -1. It's going to contain, no, not -1, but +1. Okay. +1 and 4. So it's like just identify one number and keep on adding 3 into the it. 1, 4, 7, okay, 10, and so on and so forth, and keep on subtracting 3. So if you keep on subtracting 3, what are you going to get? -2, -5, and so on and so forth. Okay, so this is the set actually. When you divide these numbers by 3, you get, what do you call, a remainder 1. How about 2? What are those numbers which have remainder 2 actually? So you can say that, okay, let's just start with 2, because I can write 2 as the 3 times of 0 plus 2. So 2 is going to come, and then keep on adding 3's actually. So 5 and I don't know, 8, right? 11, so on and so forth, and -1, -4, and so on and so forth, right? So this is really the set actually. So we have explicitly wrote these sets. By the way, someone can ask, where will be the elements? Okay, so where will be the elements of the form, say 3k plus 3? Why not there is an n that is like 3k plus 3 actually?
उससे फिर सर 3k plus 3 फिर divisible by 3 है ना, इसलिए
Exactly, so they are already here. How about why not there is a number 3k plus 5 say? 3k plus 5 जैसे नंबर वाले नंबर क्यों नहीं है? वो किधर होंगे?
तो divisible by 2 3 करेंगे तो 2 remainder आएगा.
Exactly. So क्योंकि, so here's an interesting thing, and you can see actually, and you can immediately observe this fact. So in other words, I can write this 3k plus as 3 plus 2. So therefore 3 times of k plus 1 plus 2. So all such elements are already in, you know, what do you call? अच्छा ये जो है ये S1 था, S0 and S2, yes.
2 S2.
S2 में है already. They are there actually. So you don't have to count them. ठीक है? Anyway, so when you divide a number by 3, no matter what that number is, there can be only 3 remainders actually, right? Either there is going to be a 0 remainder or a 1 remainder or a, you know, or a 2 remainder actually, not more than 2. Because if, hello, ठीक है जी, so 6 is really 6 is if you divide some number by 6, what could be the potential remainder? Could be
1, 2, 3, 4.
yes,
0.
0, 1, 2, 3, 4, up to, what do you call, 5 actually, and so on and so forth. So this is really natural. Okay, anyway, so the problem is not to find the remainders of 3, but the problem is to really check that whether this S0, S1, and S2, they partition the set of integers or not actually. So can you tell me any integer that is not present in this list? If I ask from you, for example, that, okay, tell me 35 is an integer, right? 35 is an integer. Out of S0, S1, and S2, 35 is where? Where is 35?
S2.
So it's going to be in S2, right? It's going to be in S2. So no matter what number you take from set of integers, okay, you know, all integers are present in one of these sets actually. And so therefore, this satisfies this first condition actually, that every element of the set X, okay, that you want to partition, okay, you know, there is a set inside the partition that contains your element. All right. So no matter what integer you take, that integer is going to be present in one of these sets. And how about their intersection? Is S not intersection S1? S not intersection S1 is what? Can you tell me something common in both? Can you tell me something common in both?
सर इंटरसेक्शन
Nothing.
तो 5 होगी ना.
Nothing. होगी नहीं है. ठीक है. और S not intersection S2? Nothing in
वो भी
common.
5 होना चाहिए सर.
S1 intersection S2 5 होना नहीं चाहिए, 5 है. ठीक है. 5
Yes,
है.
sir.
ठीक है. So all integers are present in one of the S0, S1 and S2, and all of these sets have, what do you call, a different intersection actually. They are disjoint. So therefore I'm gonna say, or we can conclude, that this S0, S1 and S2 are partitioning Z actually. Okay, they are partitioning. So I hope you got some idea of the partition, right?
Yes, sir.
Okay, so that's really an important thing. Next, in next part, when we were kind of proving some identities, okay, we proved the different set identities, but we didn't prove identities about the Cartesian products, the product of the sets, okay, and about the power sets actually. Acha ji, can someone tell me what should be the set builder form of a power set? What should be a set builder form? Yeah, symbolic form, whatever you have learned. Okay, symbolic form of a power set. Say I have a set A and the power set. So I hope you all know the power set. Power set is a set of all subsets, right? So what should be the symbolic form of the power set of A? कोई बताएगा?
Sir, according to the book, X is such that X is a subset of A.
So first of all, not according to the book, you know, it's really the, you know, it should be really the definition actually. So when a set is going to come inside, first of all, what is going to be inside the power set of A? First of all, the inside power set of A, there are going to be sets, right? Say B. But what qualifies B to be in the power set of A? What conditions B must satisfy to be in the power set of A? The definition of
So
the
B
power
must,
set tells you that it contains all subset of A. So if something is a subset of A, it must be in the power set of, what do you call, power set of A actually, okay? So power set of A contains the sets, okay? But what kind of sets? Those sets which are subsets of A, which satisfy this condition, okay? Which satisfy this condition actually. So if you want to prove that a set is, you know, a set is whether a given set is in the power set of A or not, just check this condition actually. Is it a subset of A? If it is, it must be an element of power set actually. All right. So that is really the set builder form of it. Okay. So what would be the set builder form for the say power set of X? So you're gonna say that power set of X means it's a collection of the sets, say A, such that A is a subset of X actually. Okay. A is the subset of X. So here A is an abstract element. Now let me prove, for example, an interesting theorem actually. So I want to prove a theorem about power set, which is a very interesting theorem. Okay. So it says that imagine you have two sets A and B, two sets. Then consider the power set of the intersection of two sets. In other words, take their intersection and then try to find all of its subsets. So, and put those subsets in this set, so you're going to get the power set of A intersection B. Then what we have to prove, that the power set of intersection B is basically the intersections of the power set actually. All right. So power set of A intersection B is equal to the intersection of power set of A and the power set of B. That's what we have to, for example, prove. All right. So how can I prove it? I'm going to say the same strategy. That, okay, this is a set actually. Power set is a set. And this guy, the intersection on the other side is also a set. And you have to prove the equality of the sets. So whenever you want to prove the equality of the sets, you need to show that, like, okay, the one side is a subset of other and the other side is the subset of the first side. So first I'm going to show that Y power set of A intersection B is contained in, say, power set of A intersection power set of B actually. So why this is true. By the way, what should I do? What should be my first step to prove this?
So take an arbitrary X
You know,
from the
okay, so I'll not represent the elements of the book might be doing it, but I'll not represent the element of power set by small x actually. I'll represent them by the capital X. So I'm saying that let capital X belongs to the power set of A intersection B. All right. Because there are sets inside the power set. So it's better not to use this notation, but to use, say, this notation that, X belongs to the power set of A intersection B. So if X belongs to the power set of B, what condition it must satisfy? What does this mean?
X is element of
X is a
element of A as well as B.
no, elementary. Na? So here's a what should be by definition, what would be the set
X
builder
will
form of?
be the subset of A intersection B.
Exactly. So power set of A intersection B contains the sets X, which are the subsets of this set actually, whose power set you are taking actually. Okay. So it contains the subsets actually of the intersection. So if X is in the power set of A intersection B, this means that X is in A intersection B. And when I can show, what should I show so that this X can belong in the power set of A and the power set of B? What should I say? What should I prove? So I must prove that this X must be a subset of A and X must be a subset of B actually. All right. But this is a fact that I have to verify. Okay. I can't just say that, okay, since X is a subset of intersection A and B, so X must be a subset of A and X must be a subset of B. The question is how you have to justify it. So the justification can come from here that, okay, let's pick, say, an element. Now you can pick an element actually. So let's pick an X from X, right? Let's pick an X from X. But I know that this X is a subset of A intersection B. Like this is what is known to me. So this means that this X must be in the A intersection B.
Yeah.
But if this X is in A intersection B, so this means that X must be in A and X must be in B actually. But I just want X must belong to A. So I picked an element, okay, and X belongs to B. What law I'm gonna apply to deduce that X belongs to A? कौन सा law apply करेंगे? From this is statement to this is statement. कौन सा law है ये?
Sir, modus ponens.
Modus ponens या modus tollens?
Sir, modus tollens.
Who knows? So इसका मतलब है याद नहीं है आपको, है? You don't remember.
सर ये थोड़े सिमिलर है ना सर, तो बस वो भूल जाते
So
हैं.
I can quote that result. It says that if you have P and Q, therefore P. ठीक है? यानी अगर P and Q statement true है, तो इसका मतलब ये है. So if the P and Q statement is true, this means that the statement P is true. So if X belongs to A and X belongs to B, so you can deduce from it that X belongs to A actually. And what would be really the consequence of this? I have picked an element from X and I have shown that it belongs to A. So X is a subset of A. That's what is really, the way to say that X is a subset of A. Why X must be a subset of B? So I'm gonna say that, okay, let's X, like this seems like trivial actually, but you have to write it, you have to do it actually. Let X is in X, and I know that X is a subset of A intersection B. This means that X must be in A intersection B, and therefore I can say that X must be in A and X must be in B. And from this I can deduce that X belongs to B because X is in both A and B. So this means that X is in B actually. Hence, I'm gonna say that I deduce that X is a subset of A actually. B, sorry. Now, if X is a subset of B, therefore, what would be the conclusion? That X belongs to the power set of A. Why? Because anything that is subset of A must belong to the power set of A. And if X is a subset of B, okay, if X is a subset of B, this means that X must be in the power set of B. And if X is in power set of A and power set of B, this means that X must be in the power set of A intersection power set of B actually. So what does this show? This shows that this is valid, that I picked an X from the power set of A intersection B and I proved that the same X would be in the power set of A and the power set of B actually, right? So this one side is shown actually, but for the equality you have to show the other side, right? Okay, so right, let's do other way around. Let's do other way around. Why the power set of A intersection power set of B is contained in the power set of A intersection B, right? So I'm gonna say that, okay, let's pick an element, say X, from power set of A intersection the power set of B, right? This means that X is in the power set of A and X is in the power set of B, right?
सर
जी जी
सर अब ये कह सकते हैं कि जो हमने ये किया है x बिलोंग्स टू पावर सेट ऑफ ए इंटरसेक्शन b, इसका रिवर्स ले रहे हैं बस.
you can say it, you can say it. Not precisely reverse actually, but you have to show it. सिर्फ जुबानी कहना नहीं है, I need an argument actually. मुझे जो है mathematical argument चाहिए, precise. अच्छा, if x belongs to the power set of A, what does it mean? इसका क्या मतलब?
X is a subset of A
Exactly.
and X
X
is
is a subset of A and X is a subset of B actually. So in fact, you can prove easily by taking an element from X that X is going to be A and B inside A and inside B, that X is a subset of A intersection B. Since X is a subset of A and X is a subset of B, so it must be subset of intersection B. ठीक है? One should not, इस level पर, we are at learning phase now, so try to prove everything. ठीक है? So how you can deduce from this statement, this seem like trivial, but try to write a proof actually. Anyway, so if X is a subset of A and X is a subset of B, so X must be subset of A intersection B. And if X is a subset of A intersection B, so it satisfies the condition to be in the power set of A intersection B. And if this is the case, what we have done? So I picked an element from the intersection of the power set of A and power set of B, and I proved that the same X is also in the intersection. So this means what? This means that the power set of A intersection the power set of B is a subset of the power set of A intersection B, right? So this is what we have proved. So the both sides of the statements are true. So therefore you have this conclusion actually. Okay, so inclusion. So power set of A intersection B is included in power set of A intersection power set of B, and you also have a reverse inclusion. Okay, so you should so you should have equality. So you should have equality. So why did I this exercise? Because there are some exercises in which you have to prove some theorems about the power sets actually. So you should have an introduction about the power set, right? ठीक है, इसमें कोई सवाल है? Any question? कोई सवाल नहीं. Now I would like to do a final bit, okay, and move towards an interesting new topic. The final bit that I would like to do is about the cross products, because there are some, you can find some exercises in exercise sheet in which you have to prove some identities about the cross products actually. Okay, so we have proved identities about unions and intersection and complements and so on and so forth, but we haven't proved anything about the cross product. So first of all, what would be the set builder form of the cross product of two sets? So imagine I have two sets A and B. What would be the meaning of what would be the set builder form of the cross product? What goes inside cross product? क्या होता है?
So there is order pair XY such that X belongs to A and Y belongs to B.
Exactly. So I can say that like the abstract representation of an element here, like you have A comma B, okay? So it contains the ordered pairs, okay, where A is in A and B is in, what do you call B actually? Okay. So in other words, what does this mean? This means pick all elements from A one by one and pick all elements from B one by one and make all such ordered pairs. So this is really the collection of all ordered pairs where the first element comes from A and the second elements come from B. So this is not just one ordered pair. This is the set of all ordered pairs, okay, in which the first element comes from A and the second component comes from, what do you call, B actually. Okay, so this is really the abstract definition of A cross B is actually. All right. So, and I, in our last discussion, I also gave you, what do you call that? What does pictorially this cross product means actually? You will have some more about this cross product and stuff in your next class when we're gonna talk about relations actually, and you're gonna see that the cross product have a beautiful, meaning actually, a practical meaning, interpretation that the cross product of two sets basically represents, what do you call, a relation, okay? And we will see those relations as well, but not now. Not now. I'm just interested in proving some identities about the cross products. So for example, I want to prove, say, an identity that goes like this, that, okay, the cross product of B union C is equal to, okay, let me say correctly. The cross product of A with B union C is equal to A cross B union A cross C union A cross, right? That, somehow you can say that cross product distributes over the union. Okay, a similar identity is also true about the intersection actually, that A cross B intersection C is same as the A intersection B, A cross B intersection A cross C. Okay, the same is true about the intersection. So I'll just prove one of these. Let me show you pictorially that what does this identity means. By the way, let's make first a picture of cross product. Okay, let's make a picture of cross product. Imagine I am in R2. Okay, and imagine I am taking A to B, say for example, an interval. Okay, so let's take this interval 0 to 1, and B is, say, another interval, I don't know, let's call it 1 to 2. Okay, so these two are intervals. So what would be the picture of 0 to 1? So 0 to 1 is going to be, so I want to make a picture of A cross B. Okay, so what you can do is that, okay, draw A is here. So like this is my A. So this is really the interval, for example, that starts from say origin and goes up to 1. So this is my A. And where is going to be my B? So B is 1 to 2. So for example, on the coordinate plane, say imagine this point is 1 and this point is what, 2. All right. So this is what is really your interval 1 to 2. Now, what are going to be the parts that are going to be inside actually? So A cross B is going to be what? So it's gonna contain say X and Y such that X is a real number in the interval 0, 1 and Y is a real number in the interval 0, 1, right? This is what is going to be the form. Now, which ordered pairs can come inside A cross B? Can someone tell me? कौन से ordered pairs आएंगे? Is 0, 1 going to be inside? होगा 0, 1 inside? 0, 1 होगा?
Yes.
A cross B. By
Yes,
the
sir.
way, where is the point 0, 1? So 0, 1 is this point, right? By the way, can I say that 0 and or maybe say 1/2 and 0 will be inside the set A cross B? होगा? 1/2 or 0?
No, sir.
नहीं होगा? नहीं होगा. अच्छा 1/2 and 1 for example, ये होगा?
No, sir.
1/2 and 1 ordered pair.
सर ये हो सकते हैं, क्यों नहीं हो सकते सर?
Exactly. तो बताया ना भाई. 1/2 and 1. अच्छा 1/3 and 1 होगा? वो भी होगा. ठीक है? और 1/5 and 1, that will also be there. Okay. So what we can say that all these points are going to be inside 1. All these points, take any ordered pair on this line and that is going to be inside the set A cross B. Do you agree with me?
Yes sir, I am.
Okay. Will this line be inside the cross product? होगी कि नहीं होगी? ये जो line होनी चाहिए ना? So you have if you have a 0, 1, 1, so should it be 0, say 3/2 inside it? नहीं होना चाहिए? So where is going to be the point of 0, 3/2? So it's going to be somewhere in the middle, right? यहाँ होगा यहाँ, somewhere in the middle. So this is going to be the part. So in fact, what I would like to tell you, this line is going to be included in the set, and this line is going to be included in the set. And not only this, but all these points which are inside this set, they are all part of the, this A cross B actually. So A cross B is really a rectangle. Actually. For example, will there be a point 1/2 and 3/2? 1/2, 3/2 होगा?
Yes, sir.
और वो कहाँ होगा? Where is going to be? Where it is going to be? So it is going to be right in the middle actually. Right in the middle. So the intuition is, I want to give you, before proving this, stuff, I want to make a picture in your mind actually. Okay. So keeping in view this notation, if I have to make a picture of the cross product, I will always picture the cross product as a rectangle in my head actually. Okay. So if I have A cross B, all right. If I have say A cross B, then I'm gonna say, maybe I must write it with this color, A cross B. Then I'm gonna say that, okay, A is maybe some horizontal line and B is some vertical line. Okay, but A cross B as a picture is going to be a rectangle. Actually is going to be a rectangle, okay, whose one side is A and other side is B, and everything inside of the A cross, this rectangle is included actually. Okay, is included. So that's really is a A cross B. Now with this notation, do समझ आ रही है बात what I'm saying actually? That whenever I have to make a picture of the cross product of two sets, okay, no matter what these sets are, they are not necessarily intervals actually and whatever. Just say when you make a picture of sets actually, you make circles, but are sets circles actually? No, you just make pictures actually, right? You just make pictures and represent the sets through the circle. So I'm saying that whenever you want to represent a set, whenever you want to make a Cartesian picture, okay, the Venn diagram of a Cartesian product, make a rectangle. Okay, make a rectangle, and keep in view that in this rectangle, one side is going to be A, horizontal side is going to be A, and the vertical side is going to be B actually. All right. So can someone tell me what would be the picture of say this first identity? So if I want to make a picture of first identity, how can I make it? How can I make it? So I'm gonna say that, okay, imagine this is my B, all right, and say a green line is my C, okay, which is a bit bigger. And okay, no, I must make these two lines vertical. Okay, but it doesn't matter, it's better to make it vertical as the notation that A should be, as we have, for example, kind of make a convention here that, like, okay, imagine this is my A, that's my A. And what is my B? Say, imagine B line is this, okay? And say the C is maybe a bigger line, maybe a bigger line actually. What would be the line for the B intersection C? Can someone tell me what B union C? What should be the line that represents a B union C?
The whole vertical line.
So you're gonna say, okay, a vertical line, like, okay, like this is my B and this is my C. So make the vertical line. Okay, this is my B. But it is quite possible that maybe these two sets B and C can have something in common actually. Okay, they can something in common. It's not necessarily that B and C are two different sets. Is it necessary that B and C should be two different sets? No.
No, sir.
So let's make a copy of C, and let's say that it intersects with the sum part of what do you call C actually. So this picture, this green and blue line combination is representing my what? B union C, right? Now what does this what would be the picture of A cross B union C? As I said, make a rectangle. Make a rectangle. Okay, so this side is colored as the same color, all right, and maybe use the same red color here. This is my C, and then I use, say, the sum part is common, same green color. Okay. maybe I put the common part as, say, for example, some other color. So this is really the common part in both, for example. Okay, this is really the common part. So what is A cross B? So A cross B union C. So A cross B union C is this entire rectangle. Okay, this entire rectangle. I'm not filling the color because I want to make another picture within it. Actually, this entire rectangle. But can someone tell me that where is A cross B? So this is okay. So this side is B union C. This side is B union C, in which say this is B and this is C and this is B and this is C. So and obviously this is A. So where is A cross B? So A cross B is basically this rectangle. Do you agree with me that this rectangle is going to be A cross B?
Yes, sir.
Yes, sir.
And where is B A cross C? So A cross C is above rectangle. And what does the identity is telling you? That if you combine A cross B with A cross C, you should get the A cross B union C. Okay, and which is this entire picture actually. This entire picture. Okay, this entire picture. I don't know. Should I put it or not? Because otherwise these all colors will be lost actually. Are you getting the point? By the way, can you think of the second identity through this picture? The answer is yes. Why not? So first of all, where is B intersection C? So the B intersection C is this part, right? Is this part, say for example, B intersection C, right? Which is common in both. Now make a rectangle of A with B intersection C. So this is going to be the rectangle. Shall I make a new picture quickly? Why I'm saying this? Because, you know, I want actually that you should think about, you know, all these identities, not in this boring and a logical symbolic way, but you should be able to also make the pictures actually. You can see through it actually, that really it works. So that's my A. Okay, so that's my A. And this is my, say, I don't know. So I must use the same color. This is my C. No, what was the color that I used? I use red color here. Okay, so okay, to make the similar picture, let's use the same colors. All right. So A is I don't know. कुछ समझ आ रही है बात भाई? Are you getting anything?
Yes, sir. I am getting.
Yes, sir.
ये
Yes,
A है.
sir.
So this is my A. And I don't know. Where is my C? A तो फिर भी मैंने गलत कलर दे दिया. So I picked the wrong color actually. Okay. I'm very bad at colors. You know. So this is my A. And let's make another copy of A because I want to cross product would be a rectangle. And this is my C. And say this is my B. All right. And like this part is say common in both actually. Again, this is my C. All right. This is my C. And this is my B. And this part is really common. Okay. So let's give some name to it. That okay, this is A, this is B, this is C, B and C, and this is A, and this common part is really B intersection C. B intersection C. Now, what does this says? The identity says that, okay, take the cross product of A with the intersection. In other words, make a rectangle with a base A and height in B intersection C. So where is that rectangle? So how can I make it? Okay, so let me make this rectangle. So this is really the rectangle that you are talking about. That's your. You agree with me that ye rectangle hoga?
Yes, sir.
Yes, sir.
Okay, this blue part. But the other side is telling us. Other side is telling us an interesting thing. It says that you can also get the same part by first making a rectangle of A cross B and a rectangle of A cross C, and then see what is common in both. You should get the precise same rectangle. So how can I see it? So let me use some, I don't know, some other color. So where is A cross B? So the A cross B is, maybe the B is up to some this point and B is up to say some this point. So make a rectangle up to B कहाँ तक होना चाहिए? B यहाँ तक होना चाहिए. ओहो. B का तो दौरानिया है. ऊपर वाली लाइन होनी चाहिए ना भाई. Okay, so this is my, okay, this is this line up to the, नहीं, B is ये तो हो गया A. Okay, this is A, and this entire is B actually. So I'm talking about this rectangle. ठीक है? तो ये जो rectangle है, I don't know what color should I put. So let's put yellow color. This yellow part is what? This yellow part is A cross B, right? C कहाँ तक है?
Yes, sir.
I don't know what color should I use. I'm really bad at colors. So the C is up to this part, up to this blue line actually. ठीक है? So this entire is C, and this is, say, this blue line is A, and then take the cross product. All right. So can you see where they are meeting all? Where the yellow and blue lines are mixed. It's again, the same rectangle. The same rectangle actually. The same rectangle. Same rectangle. All right. So the picture. So this is really the picture. So that's how you make the picture of the given identity. And this is important actually, that we shouldn't only just prove the things and without understanding. You should make a picture. You should be able to picture in your head that what are the given identities saying. Okay, so whenever you are solving an exercise or a problem about the cross product, okay, I encourage you to first make a picture of it, make yourself comfortable with it, make sure you are convinced about that through picture, and then try to write a proof of it actually. Okay? So this is also an important part of the thinking process actually. समझ आ रही है?
Yes, sir.
Yes.
Okay,
Yes, sir.
चलें जी. So let's now prove one of the identities. Okay, let's do the logic part. Okay, so you see, you don't have to. That's what the beauty of this is actually, that you don't have to, make all kind of picture to prove this identity. The picture is there for you to make, to see that there is a life behind this boring identity. Okay, There is a meaning behind this boring identity. Anyway, so I have to prove this. So how can I prove it? So I need to show that A cross B union C is a subset of A cross B union A cross C. By the way, book proves, say, the equality in a direct manner. It doesn't show that, okay, one side is a subset of other and the other side is a subset of one. But I want that you shouldn't do it like book actually. You should do it, the way we are doing it actually. Okay? Because in this manner, you are explicitly seeing that, okay, why all elements of this sets are present here and why elements of all this set are present, say, for example, here actually. Okay. Anyway, so what should I do? What should I do? So let's take, say, let's take an element from cross product. Okay, so let's take A cross B union C. By the way, what kind of elements are going to be inside the cross product? किस किस्म के elements होंगे?
ordered pairs.
Ordered pairs होंगे. So let's take an ordered pair XY that belongs to A union B cross C. Now by definition, what does this show? This shows that X must be in A and Y must be in B union C, right? And but this and is not intersection. You have to keep in view. ये and जो है intersection वाली and नहीं है, ये cross product वाली and है, ठीक है? या comma रख दे बीच में, doesn't matter. Okay, so X belongs to A and Y belongs to B union C means Y belongs to B or Y belongs to, what do you call C? ठीक है जी. And so what should I do? What should be the next step? I can also write this as X belongs to A, distributivity, X belongs to A, and Y belongs to B. Okay, or X belongs to A and Y belongs to B. By the way, we talked about this in very much detail actually, right? In our last discussion, that how to justify all this actually. So X belongs to A. So I can say that, I can rewrite this statement as X belongs to A and Y belongs to B. So this is one possible case. Or what can happen? So X is in A for sure. Now for Y, I don't know that whether Y is in B or Y is in C or Y is in both actually. Okay. So I'll consider these cases separately. So imagine the case that when X is in A and Y is in B, or what can happen is that X is in A and Y is in C actually, right? And what would be the meaning of this? The meaning of this is going to be that, okay, X comma Y is in A cross B, because this and does not mean intersection. It's really the cross product and. Or XY belongs to A cross C, right? So either XY is going to be inside A cross B or XY is going to be in cross A cross C, right? And therefore, what did you get? The XY belongs to A cross B union A cross C, right? So that's how we shown that if you pick an element from A cross B union C, you can also show that the same element is here actually in A cross B union A cross C. ठीक है जी, समझ आ रही है बात? Are you getting it?
Yes, sir.
Okay. But let's show the other side separately. So A cross B, by the way, it's going to be on same lines, but you have to carefully do it. At this time, don't make any shortcut. Write details, because this is your first course actually. This is where your writing and thinking habits are being developed. So if you got habitual of writing short, or maybe if you got habitual of taking shortcuts, actually probably you will not learn in future actually. So don't take shortcuts. Okay, if you think something is trivial, ye to obvious hai, like this is obvious actually, ye main kyun prove karu, why should I prove it? Okay, so it's nothing is obvious. Try to justify everything. See that why a thing is zero. Okay, why, for example, this statement is equivalent to this statement. Okay, I'm not going into the details of it because we went it last time actually. So you can apply the same strategy to deduce that why. For example, this statement is same as this statement. So never go for the shortcut. Try to justify it, try to write it, try to convince yourself, try to convince your peer. Whenever you are writing it, you have to keep in view that you are not writing for yourself. You are writing for for another reader. So your reader should not use his intellect to interpret your things, or her intellect. It's your responsibility that you should communicate and communicate things clearly. Anyway, so let's show that A cross B unions A cross C is a subset of A cross B union C. All right. Now, what would be the abstract element in this form? So it's going to be ordered pairs, because this is the union of ordered pairs with the set of ordered pairs with another set of ordered pairs actually. So in fact, in this union, you're going to have ordered pairs. So let's take, say, X and Y from A cross B union A cross C, right? So this means, by law of logic, the definition of the union, that X comma Y A cross B are X comma Y must be in A cross C. See, whenever I am using a law, I'm saying it with my mouth actually at the moment. But for example, if you are writing a proof, actually you should mention actually that what you have used. So I have used the definition of the union. Okay, I have used the definition of the union to go from this step to this step. And similarly, what does X Y, what is the meaning of X comma Y belongs to A cross B? So it means that X must be in A and X must be in B. All right, or X must be in A and X must be in C.
Sir,
जी
sir, यहाँ पे sir y must be in b होगा x.
oh sorry, Y होगा, yes, Y होगा, yes, you're right, like this. This guy must be Y. ठीक है, thank you. Now I can say, no matter what happens, like either this case occurs or this case occurs, X is there actually. In both cases, X is an inside A. So you're going to say that, okay, X is an inside A. But about Y, I don't know that whether, Y is going to be in B or Y is going to be C. And Y belongs to B or Y belongs to C. Okay. Again, by the laws of logic, the distributive laws of logic. And hence, I can say that X must be in A and Y must be in B union C. So therefore, X must be in A cross B union C. Okay. So this really shows that, you know, that this identity is also valid. And if the both sides are subsets of each other, like this side is subset of this and this is subset of other, so they must be equal actually. Okay? They must be equal to each other. Okay, so this is what is really the proof of this identity. So you can prove the identity, the second identity for yourself, and similarly you have also exercises to prove in theorems to prove in the exercise actually. So try to do the proofs, try to do as much as proofs you can do, try to solve all these exercises with their justification. So always don't write a proof like me, because I am saying my justifications from my mouth actually, but when you are writing it, okay, to be read by someone else, then you should mention the properties. For example, in the book, when you see that he's proving something, in the bracket he writes the explanation of that, why and what law he is applying in order to prove, in order to go from one step to another step actually. इसमें कोई सवाल है तो पूछ ले, if you have question do ask actually. कोई है सवाल? If there is, जी
Sir,
जी
sir, logical distributive and sir distributive law में कोई sir difference है sir?
लॉजिकल डिस्ट्रीब्यूटिव लॉ, जो सेट का डिस्ट्रीब्यूटिव लॉ है, is really the distributive law of logic, or it's a corollary to the distributive law of logic. So distributive law of logic is general actually. बाकी ये नतीजे हैं सारे उसके. So all these are results actually of it. ठीक है, जो distributive properties आपने पढ़ी हैं about sets या about, say for example, तो वो सारे consequences हैं in distributive laws के. ठीक है जी. Anyway, so what we're gonna do now, it's 10:34, right? So let's do a six minute break. Let's meet again at 10:40, all right? And start a new topic actually. Almost, took 10 minutes. Anyway, so let's just start with, let's get back to this discussion. So the next important thing that we have to kind of learn and deal with is to move towards the generalized unions and intersections actually. Okay. It's very much analog to what you did in the summation. Okay, so when we introduce the summation notation, so we know that the summation notation is a kind of a clever way to write the big sums in a simple thing. Okay, so here's the thing. I know what is De Morgan law of sets for two sets. Okay, so A union B complement is same as A complement intersection B complement. How about if there are three sets, say A union B union C complement? Okay, so what would be the okay, what would be this on the other side? क्या होगा other side, दूसरी side पे? Andy, can you hear me?
Yes, sir.
Yes
So
sir.
what are you gonna get on the other side?
A complement,
A
intersection,
A
complement, intersection.
complement, intersection B complement, intersection C complement, right? But imagine now I have to write A union B union C unions, D, okay, B union C union, I don't know, D, and somehow say I go up to the union Z actually. Okay, so Imagine that you have lots of sets. Okay. So A union B union C union Z, and you want to write it. It's, for example, De Morgan law. So what's it gonna be? So A complement intersection, B complement intersection, C complement, and so on and so forth, and intersection Z complement. Right? Now, the trouble is that, okay, if I go beyond Z actually, so I want to add N1 and another actually, so I'll be out of letters. Okay, so I have A, B, C, D, and what do you call, say up to Z. Say if I want to add another element here, so what name should I give to it? So all A, B, C are exhausted. So what should I do? क्या करना चाहिए? So for example, I want to write A union B union C union, say T union, and so on and so forth, union Z, and I want to write another union. So what letter should I choose? क्या करना चाहिए?
A star or A.
So you have to create a new notation, maybe A star or B star or C star. Okay, so again I'm going to say that maybe you added A star and union B star and so on and so forth, say union Z star, and you want to add another thing. So what are you going to do?
Sir, prime.
So you're going to create new notation. Okay. But what about if I say this? Okay, so here's the thing actually. Rather than writing, say A union B, why shouldn't I give them index actually? I say, okay, so write A1 union A2. Wouldn't that be a good idea? Okay.
Yes, sir. Good.
Complement is going to be A1 complement intersection A2 complement. So if you want to write, say, 3 sets, you're going to say A1 union A2 union A3 and its complement. You're going to say that A1 complement intersection A2 complement intersection A3 complement, and so on and so forth. Right? Now, you will not run out of the natural numbers. You can have as many as numbers you like actually, right? So you don't have to give the stars and the primes and the double star or the double prime or whatever. Okay, so indexing would be a good idea. You agree with me?
Yes, sir.
Okay. But now, say, imagine I say to write explicitly A1 union A2 union A3 union A4 union A5 union A6 union A7 union A8 union A9. Oh, you're going to say, oh my God, what's going on? Huh? Union A10 and so on and so forth. I give you a task to write, say the unions up to 100 actually. So it would be really a messy thing. So if I give you to create a notation actually, what notation you're going to give? So like, for example, in sum, we said that, okay, if you have 1 plus 2 plus 3 plus 4 plus so on and so forth, 5 plus 6 plus 7 plus 8 plus 9 plus 10, rather than writing this, you do what? Sum what? K from where? Starting from 1 up to 10, right? So that's really a compact way to write this entire sum. So if I give you an opportunity to create a compact way to write this above union, so what do you think? What should be the best way to do it?
Same sir, submissions.
Summations not kare. Let's call it, let's do the union. Okay? Union. Of what? Of say A and what is this sequence? 1, 2, 3, 4. So what would be the general form of this sequence is going to be K. Then let's do the unions of AK starting from where? 1 and up to K equal to 10. So don't you think this is a very compact and a nice notation?
Yes, sir. Of course.
So
Yes,
what I'm
sir.
doing, I'm saying A1 union A2 union A3 union A4 up to A10 actually. So I don't have to write it. And I can then go to 100 and 1,000 and 10,000 and a million, whatever. So you don't have to, you don't need a lot of space to write this stuff. You can really, do it easily, right? Is it making sense? Good.
Yes, sir.
Yes, sir.
That's a general union. How about instead of say a sequence, I have like 1, 2, 3. I have like this: A1 union, A3 union, A5 union, A7 union, A9. So if I want to put them in a compact notation, what do you think? What should be the way to do it?
Sir, AK should be changed in
Yes. So I'm gonna say let's do union of what? A and the index. Index. What is the general term for the index sequence actually?
2K minus 1.
2K minus 1, right? So 2K minus 1, right? Where the K goes from where to where? It goes from 1 so that you can get a 1. And how you can get a 9 actually? So it
Equal
goes
5.
up to, what do you call? 5, right? It goes up to 5. Are you getting the point?
Yes,
समझ
sir.
आ रही है बात? Good. अच्छा जी. So now you see that you got a very interesting way to write the unions. By the way, if I have to write, say a De Morgan law, okay, a De Morgan law in more general sense actually, okay, a De Morgan law. So how does my De Morgan law should? So in other words, I have A1. By the way, the thing that I'm doing with the union, I can also do the same thing with the intersections actually. So if I have A1 intersection A2 intersection A3, say up to intersection A10, so what would be the compact way to write it? Or what should be the compact way to write it? That I am doing the intersection of AKs where the K goes from 1 and up to 10, right? That would be the way to write, what do you call the intersection is. समझ आ रही है बात? ठीक है? So now
Yes, sir.
if I write, for example, the De Morgan law for n sets, so A1 union A2 union A3, so on and so forth, union AN, okay, and its complement. So there are n sets. I'm taking their complements, so it should be equal to what? A1 intersection A1 complement intersection A2 complement up to intersection AN complement, right? But that's a boring way to write it. So what would be the good way to write it? So I'm going to say union. So if I take the union of I equal of A, say I's or AK, whatever, doesn't matter, from 1 to n, and then I compute their complement, this is same as that I'm going to get the intersection of what AI complements, where the I runs from 1 to I equal to n. You agree? समझ आ रही है बात भाई?
Yes, sir.
Good.
Yes, sir.
So imagine now I have to write a general distributive law. Okay. I have to write a general distributive law. For example, I'm saying that, okay, I have a set A, that I want to do the intersection with, say, a general union. Okay, so A1 union A2 union A3 union A4. All right, so it should be equal to what? By our boring way, it should be equal to A intersection A1 union A intersection A2 union A intersection A3 union A intersection A4. So, it takes a lot of time. But how can I write it with the compact notation? So I'm gonna say this side. So can someone help me out that how should I write it? That I am taking the intersection of A. So A intersection with what? With this union, right? This union. And how can I write this union? So union is that I am taking the union AI, where I goes from 1 up to what?
N.
4 4 है ना? N no,
So
n
sir.
रख देंगे. So if there is n, you can write n, but there is 4 actually. So A intersection union of AIs, where I goes from 1 to 4, is same as what would be the form of these sets. How should I write it? J
Sir, union, sir.
union that goes
Union,
from
I is equal to 1.
to
I is
I
equal to
4 union of what? A
the bracket
intersection AI
A
intersection AI.
intersection A. Yeah,
I.
yes, sir.
Yes. See, this is what is going to be. So what would be the generalized one? That if you have A intersection union of I equal to 1 to n AI, this is same as union of I equal to 1 to n A intersection AI. So this would be the general, what do you call, law of distributive law. Are you getting the point? Similarly, I can write A union, say the intersection of I equal to 1 to n AI, right? So this should be same as what? Intersection that goes from I equal to 1 to n and A union AI. समझ आ रही है बात? ठीक है? So this is a very clever way to write these big unions and intersections. ठीक है? These big unions and intersections. Here's the thing. Now, how to prove such identities? If you have been given such identities, how to prove it actually? So let me say, if there is a question, do ask actually, beta. इसमें कोई सवाल हो तो पूछे. कोई सवाल नहीं. चले. First of all, if you have a union that goes from I equal to 1 to n, okay, and AI. By the way, what would be the meaning of X belongs to this union? Means what? I know what is the meaning of X belongs to A union B, that X is in A or X is in B. But if you have X, okay, so let's use indices rather than writing this. So if I say, imagine that I have an X, okay, I have an X that belongs to, say, A1 union, A2 union, A3 union, A4. So what are you gonna say? क्या कहेंगे आप?
सर ए सभी में है सर. X सर
सभी में?
में है. It means that A belongs to A or A1 or A belongs to
Yes.
A or
So so the boring way is that X belongs to A1 or X belongs to A2 or X belongs to A3 or X belongs to A4. So can you tell me a quick way of writing it? So how can I put, like these are 4 actually. What if you have 100? 100 हो तो क्या करेंगे? ये लिखेंगे X belongs to A1 and X belongs to A2 and X belongs to A3 or X belongs to A4. क्या लिखेंगे? क्या करेंगे? So what should be the quicker way to say it actually? What do you think? So the quick way to say is, the better way to say this is that I'm going to say that X belongs to AK or AI. Okay, X is going to be, so in other words, when I'm saying that X is in A1 or X is in A2 or X is in A3 or X is in A4, that means that X is in one of these AIs actually. Okay, X belongs to AI for some I equal to 1, 2, 3, 4. ठीक है, ये बात समझ आ रही है? इसका क्या मतलब है? What is the meaning of that? X belongs to AI for some I equal to 1, 2, 3, 4. इसका मतलब ये है कि भाई X में भी I equal to यानी AI यानी I equal to 1 में हो, यानी A1 में हो, maybe X A2 में हो, maybe X A3 में हो, maybe X A3 में हो. So therefore you are saying that there is, out of all these indices, there is at least one index. Okay, that index can be 1, that index can be 2, that index can be 3, that index can be 4. Okay, in which X belongs actually, in which X belongs. समझ आ रही है बात?
Yes, sir.
So whenever I have to write this, I'm not gonna say X belongs to A1 or X belongs to A2 or X belongs to A3 or up to X belongs to AN. I'm not gonna do this boring way. I'm gonna say that X is in some AI for some कहें या for at least one, ये भी कह सकते हैं, at least one of I equal to 1, 2, 3 and up to N. Would that be a good way? अच्छा तरीका होगा? ऐसे ही
Yes,
होगा
sir.
ना? ठीक है ना? यानी किसी ना किसी X AI में होगा. How about if I say that X is not in union of I equal to 1 to N AI? So what are you gonna say? So you can get a motivation from this that, okay, X does not belongs to A1 intersection A2 intersection A3 intersection A4. What does it mean? इसका क्या मतलब है? इसका मतलब यही है ना कि भाई X does not belongs to A1 and X does not belongs to A2 and X does not belongs to A3 and X does not belongs to A4. Right? यही मतलब होगा.
Yes, sir.
So what should be the compact way to say all this in a single statement? कोई आप बता सकते हैं कोई तरीका कोई इजाद करें अगर, if you invent a method to say this, how are you gonna say it?
Sir, X does not belongs to AI for all I equal to 1, 2, 3.
Exactly. That's a very good thing. So I can say that X is not in AI for all I equal to 1 and 2 and 3 and actually. समझ आ रही है बात? ठीक है. So I'm gonna say that X belongs to AI. X does not belongs to AI for all I equal to 1, 2, 3 and up to N. No matter what I you take, X does not belong to AI. ठीक है जी? How about if I say that X belongs to the union, intersection of I equal to 1 to n AI? इसका मतलब क्या होना चाहिए? What should be the meaning of it?
X belongs to AI for all I
Sir,
equal to
X
1.
Exactly. X,
सभी
yes, X does not belongs to AI for some or for all.
For also.
For all होना चाहिए क्योंकि सब में होगा तभी intersection में होगा. If X is going to be in all A's, then it will be in the intersection actually. For all I equal to 1, 2, 3 and up to n. Right? That's what it means. How about if I say that X does not belongs to the intersection of I equal to 1 to n AI? What does it mean? What would be the outcome?
X does not
Sir,
belongs
X
to A.
does not belong to one.
There,
Yes, so you're gonna say that X does not belongs to AI for some, at least there is one. For some लिखें या at least one लिखें, doesn't matter. Some से मुराद है at least one. I, that is 1, 2 and up to n actually. In other words, X अगर intersection में नहीं है, if X is not in the intersection actually, that means X, it is possible that X is not in A1, or maybe possible that X is not in A2, maybe it's possible that X is not in A3 and so on and so forth. Are you getting the point?
Yes, sir.
yes, sir.
Good. Good. अच्छा जी. Okay. So now let's make it more general. We'll prove the theorem soon, okay, for generalized notation, but let me introduce the generalized notation step by step. How about if now I say that I have A1 union A2 union A3, like the sequence is, I know that the series is always not finite actually. So you can have 1 plus 2 plus 3 plus n, okay, but you can also have a series like this, 1/2 plus 1/4 plus 1/3 plus 1/6, which does not end. It's an infinite series actually. So as you can write this as a sum that goes from 1 to n I can also write this series as a sum actually, that this is 1/2 power I, where I goes from 1 and goes up to what? I don't know. So I'm going to say infinity. I'm going to say infinity, right? So that would be the way of doing it. So similarly, if the union is not finite, so it's like A1 union A2 union A3 and so on and so forth. So what would be the way to write it? The way to write it is that, okay, so the notation that I'm going to use, that I'm taking the union of AIs where I starts from 1 and goes up to infinity. Goes up to, what do you call, infinity. समझ आ रही है बात? हाँ जी?
Yes, sir.
अच्छा.
Yes, sir.
But there's another clever way to write it actually. एक और तरीका भी है. I can also say that I'm taking the union of AIs, ठीक है, where the I belongs to the set of natural numbers. अब इस notation से क्या मुराद है? What is the meaning of this notation? That I am taking the union of AIs where I's are all natural numbers. So what are the natural numbers actually? It could be 1, could be 2, it could be 3, could be 4. ऐसे ही है ना भाई? So in other words, saying this is the same as this actually. So when I'm saying that I am taking the AIs where I start from 1 to infinity, what actually I'm saying is that I'm taking the union of ai's where I is a natural number actually, because I know that the set of natural numbers is 1, 2, 3 and so on and so forth. समझ आ रही है बात?
सर
जी जी
I belongs to n, इसमें हमें ये क्लेम देना नहीं पड़ेगा कि n इस नंबर से स्टार्ट हो रहा है।
नहीं n जो है ना सेट ऑफ नेचुरल नंबर्स है। So set of natural numbers, we know that it starts from 1, 2, 3 and so it starts from 1 actually. It goes up to 2, goes 3 and so on and so forth. So यहाँ पर भी तो यही कह रहे हैं ना, it goes from I equal to 1 to infinity. ठीक है? So similarly, I can write in the intersection that what would be the meaning of intersection of ai's where I goes from 1 to infinity. I can write it in this manner. It's fine. There's nothing wrong in it. But I can also write this in this form actually, that I am taking the intersection of ai's where the indices of the I are chosen from the natural numbers. Okay, are chosen from the natural numbers. Now, what is the natural number? In natural number, you have 1 and 2 and 3. So for every index, so for every I in natural number, I am taking the intersection of ai's. समझ आ रही है बात?
Yes, sir.
So this is what another way to set it. So whenever I'm writing a set in the index, so what I'm saying is actually that, okay, as many as elements are in this set, I'm taking their intersection. Okay, so I'm taking their intersection actually. Okay. But what if the set is like this? That, okay, I have say A2 union, say A4 union, A6 union, A7 union, A8, so on and so forth. So this is a union that I would like to write. How are you going to write it? One way could be that, okay, I am taking the union of A2i's, right? You लिख सकता हूं, where the I goes from 1 to infinity. You agree with me? I can write it in this manner.
Yes, sir.
But I can also write this in this interesting manner, that I'm saying that I'm taking the union of AK's, okay, where K belong to a set I, where I is this 2, 4 and 6 and 7 and 8 and so on and so forth. Would that be a good way? Ji?
Sir,
Ji.
sir, 7 sir, 8 नहीं होगा ना sir.
क्या मतलब? No. In this case, okay. So in this case, you don't have to write like 2K here.
7 sir.
अच्छा 7 नहीं होगा, sorry 7 नहीं होगा, obviously 7 नहीं होगा, ठीक है. So even 2, 4, 6, 8.
7 तो sir.
नहीं 7 नहीं होगा, for sure 7 नहीं होगा, ठीक है. So as I always say, अच्छा जी इसमें 7 ना डालें, ठीक है, इसको निकाल दें, ठीक है, इसको निकाल दें पहले for now. So I'm going to say that, okay, I have AKs where K belongs to I and 2, 4, 6, 8, so on and so forth. ठीक है. But for example, if I have to represent, say, A1, I don't know, A1 intersection, A2 intersection, A5 intersection, A10 intersection, A11. ठीक है. So can I write it in a single intersection? What would be the way to write this in a single intersection? कोई बताएगा?
Sir,
JJ.
sir, intersection.
So let's take intersection. So see, there is no pattern here. 1, 2, 5, 10, 11.
belongs 1.
हाँ जी, क्या होना चाहिए? So what I can write is this. Anyone else? जी कोई और बताए, इनकी इंटरनेट का प्रॉब्लम लग रहा है. Anyone else?
2a minus 1, sir. Pattern, sir, 2a.
2a minus 1 बन रही है. नहीं, 10 के बाद 11 भी है ना. So you don't have to write a pattern actually. You don't have to write the pattern. So you can say, okay, I am taking the intersection of AI, where the I is in the indexing set I, and this indexing set I is really, what do you call, 1 and 2 and 5 and 10 and 11. Simple. ठीक है? Simple. समझ आ रही है बात? So that would be a clever way to write it, that okay, put these indices in a set and then say that I'm taking the intersection of AIs where the I is in the index set I actually. समझ आ रही है बात? And
Yes, sir.
all these can be all these can be put into this, for example, general index notation. All of these can be put into in this general index notation, that if I, which is the indexing set, say it is a set of natural numbers. Okay, could be set of integers, could be set of rational number, but it's enough to have set of rational numbers, natural numbers. You can say I is some subset of natural number, and I don't know what is inside of it. So if I is a subset of natural number, what could be I? क्या क्या हो सकता है? I could be the entire set. I could be some finite set like 1, 2. I could be like, okay, 1, 3, 5, and 7. I could be like all even numbers 2, 4, 6, 8, and so on and so forth, right? So I can be anything out of all these sets actually. So I can be anything. Then if I is a subset of n, then I can write that, okay, I'm taking the union of AIs where the I belongs to the index set I actually. Now I am saying that this notation contains A1 union A2 as well. It contains A1 union A2 union A3 union A100 as well. It like this also captures, say, A1 union A5, A3 union A5 unions A7, so on and so forth. In other words, all these different kind of possible unions that you have, finite or infinite, they all are put in a single notation. समझ आ रही है बात? These all are really the consequence of this single notation. इस single notation में ये सारी आ गई. Because for this union, the index set is going to be 1, 2. Say for this union, index set is going to be what? If I take, say, 1, 2, and up to 100, that would be really, what do you call? So I can write this this union, this entire union, in such a form. So this is really the very generalized way to write the unions and intersection actually. All right, so the theorems that you have to in your next part prove are the theorems regarding such unions actually. Okay, समझ आ रही है बात? So now I want actually that you should keep the description, okay, of this, that okay, if you have the union of say I belongs to I, AI, where I is some subset of natural numbers, then what is the meaning of X belongs to union of I belongs to AI? What should be the meaning of it? कोई बताएगा? इसको मैं elements के terms में कैसे लिखूं? As I say that X belongs to A union B is X, you know, this means that X belongs to A or X belongs to B. But what should be the meaning of X belongs to the union of AIs? क्या मतलब होना चाहिए?
Sir, X belongs to AI. There exists I belongs to I.
Exactly.
Capital I.
So एक तो I जरूरी नहीं है कि लिखे, ठीक है? Like this is a general notation. You can say that X belongs to AJ. Okay, I don't know that what is this index J. Okay, for some J in I. ठीक है, so I, मुझे नहीं पता कि I क्या चीज है. What is the set I? I don't know. You know, maybe the I is 1, 2 or 1, 3, 5 or 2, 4, 6, 8 or 1 to 10 or 1, 2, 5, you know, 10, 11, doesn't matter. So when I am saying, okay, so when I am saying that X belongs to this union, okay, X belongs to this union where the union is taking over an indexing set I, so I'm going to say that X belongs to some AJ. Okay, I'm not using the I, so that I'm not using the same notation I here, because you shouldn't confuse this I or the I here with this I here actually. Okay, so I'm going to say that X belongs to some AJ for some J belongs to I actually. In other words, that there is at least one index in the set I in which AJ, you know, is there actually. Could be in A1, could be in A2, could be in A3. I don't know. So there's at least one index, say 1 or 2 or 3 or, you know, 10 or whatever, in which X is there actually. So that's really a shortcut way to write it. इसमें कोई समझनी है चीज तो जरूर पूछे. By the way, what would be the meaning of X does not belongs to the union of I belongs to I AI? क्या मतलब होना चाहिए? What do you think? What should be the meaning of it?
X does not belong to AJ for every
Yes,
For all.
exactly. X does not belongs to AJ for all J in I. Okay. For all लिखे, for every लिखे, for any लिखे, for each लिखे, whatever, doesn't matter. ठीक है? For all J in I. How about if I say that X belongs to the intersection of I belongs to I AI, इसका क्या मतलब होगा? So what should be the meaning of it?
Sir, A belong to
A belong
AI
to
for all.
A
I
or
belong to.
X
belongs to AJ
AJ for all
X belongs to
J in I.
J belongs to I.
In other words, no matter what index you take, you know, if X is in the intersection of, you know, A1 intersection A2 intersection A3 up to A10, you know, it's in the all intersections actually. It's in the all sets, right? So we should write this. So that's a very sensible way to say it. How about if I say that X does not belongs to the intersection of I belongs to I and AI? So what does that mean? So हम ये कहेंगे कि okay, if this is not true, then I'm going to say that there is at least one of the AIs in which X is not there. In other words, I'm going to say that X does not belongs to AJ for some J belongs to I. In other words, what you can do is simply negate this statement. What is the negation of this statement? The negation of this statement is that okay, X does not belongs to AJ and for all will become for some. Okay? So this is really the negation, actually, logical negation. समझ आ रही है बात? So these are the terms and the notation that you have to use in proving, you know, your required, your required identities. Actually, so let me prove say some identities. Let me prove at least one or two identities with this notation, and then you can do the exercise. So let's prove the generalized De Morgan law. Okay, so let's prove De Morgan's law. So what should be the general De Morgan law? That imagine you have a subset, indexing subset I of natural number, could be any indexing set. Then the union of I in I, AI, and complement is equal to the intersection of I belongs to I and AI complement. You agree with me that this is a reasonable statement for De Morgan's law?
Yes, sir.
It's a pretty reasonable statement for De Morgan's law. ठीक है, लग रहा है कि भाई को दो लोग ही बैठे हैं, बाकी सोए हुए हैं. All others are sleeping. Is just one or two people actually who are.
No, sir. We are listening.
चले listen कर रहे हैं तो अच्छी बात.
Yes, sir, we are listening.
Good. अच्छी बात. चले जी. So this is a set and this is a set and I have to prove the equality. I want to prove this equality. So how should I prove it? So I need to first show that this union of I belongs to I, AI, and its complement is a subset of intersection of I belongs to I and AI complement, right? By the way, when you are proving this, you are proving all kind of De Morgan law. जब ये prove हो गया, if you proved this, you also proved this actually, A1 intersection A2 intersection A5. No matter what kind of, no matter how, many terms you take, okay, all kind of, De Morgan's laws are proved actually in this single statement actually. So it's a very powerful result. So it's true for, finite numbers and also true for the infinite number of sets actually. Okay, because the indexing set can be finite set and it can be. So it's a subset of natural numbers. So subset of natural number can be finite and can be infinite as well. Okay, so how to show it? So let's show it actually. So let's use some other color. So I need to what? I need to pick an element from this union of I belongs to I, AI complement. So help me out. What should I do? What does this mean? What would follow from here? If X is in this union, complement of the union, what does it mean? So you're going to say that X does not belongs to
AI, sir.
any AI, X does not belongs to this union. I belongs to I and AI. They're going to complement. If there is something that is in complement, that means that thing is not going to be inside the set. And we just saw previously that what is the meaning of a set not being inside the union actually. क्या कहेंगे? So I'm going to say X does not belongs to, say, a J for all J in I. Okay? No matter what J you take, X is not in there because it's not. Nahi. हाँ ठीक है, ठीक है, ठीक है जी. By the way, if X is not in AJ for all J in I, then where it is?
AJ complement.
Exactly. So X belongs to AJ complement, and you have to say that this is true for all J in I. Okay, this is true for all J in I. So if it is in X is in all AJ complement for all J in I, what does it mean? I can say that this means that X belongs to the intersection of AI, whether you put I or J doesn't matter, AI complement such that I belongs to I. Actually, you agreed with me? If X is in all AJs, that means that it is going to be in the intersection of all, AJs actually. So you picked an element from here and you proved it that it belongs here actually. So you're going to say hence this union of I in I AI complement is a subset of intersection of I in I AI complement. Okay, this is what that you should. How about other way around? Now we want to show that the intersection of I belongs to I AI complement is contained in the union of I belongs to I AI whole complement, right? And in order to show this, what you have to do, you have to pick an element from X intersection I belongs to I AI complement. This is going to be same as what? That X belongs to AI complement for all I in I. And if this is the case, then where it is not going to be. So I'm going to say X is not in AI for all I in I. ठीक है? और इसका मतलब क्या है? If X is not in AI for all I in I, then I can say that X does not belongs to the union of I belongs to I AI. You're just going reverse actually. देखिए ना भाई, if X is not in AI, then it's not going to be in union for sure. And if it is not in the union, where it is? It must be in the complement of I belongs to I AI complement. Okay, this is what that you should. And this shows that, okay, like this guy is a subset of this. And this shows that this generalized De Morgan law is true. Okay, generalized De Morgan law is true actually. Okay, this is how you have to kind of prove the identity. The proof is not difficult, but you have to really grasp the meaning of the notation actually. Quite often people are confused with the notation, and that's what creates the trouble. So make yourself comfortable with the notation. Is just a fancy way to say the same things. Okay, so try to familiarize yourself with the notations and try to, make yourself comfortable with the notation. ठीक है? What that I want. एक और example करते हैं. Let's do another example. Let's prove, say, generalized distributive law. Okay, so generalized distributive law. Generalized distributive. By the way, can someone give me the statement of generalized distributive law, say union over addition, union over intersection? कोई बताएगा कि क्या कैसे लिखना चाहिए? So I am taking the union of A with what? Union
The intersection P.
or maybe intersection of I belongs to I A. Right? So I am taking I'm unioning the A with these intersection. So this should be equal to what?
Intersection
Intersection
एक
of,
intersection होगी union के साथ.
exactly, intersection of I belongs to I, A union AI. Right? This is what really is the most generalized version of distributive law with respect to kind of union. समझ आ रही है बात? Okay. So now let's prove it. Let's prove it. Let's prove it that why this is true. So I'm gonna say that okay, let's first show that A union intersection of I belongs to I, AI is a subset of intersection of I belongs to I, A union AI, right? So let's say that this is true. Let's prove this. Okay. So how I'm gonna prove it? So let's pick an element from this side and show that it's also in here. Let's pick an element from here. So I'm gonna say that let X is in A union intersection of I belongs to I, AI. Right? You have to stick with the definitions. So the definitions are the key thing. So if X is in A union this set, what does it mean? This means that either X is in A or X is in this union actually. You agree with me?
Yes, sir.
Union नहीं बल्कि intersection
sir.
intersection होगा. This must be intersection. You have to. You have to. And then I can say that okay, X belongs to A. R. What would be the meaning of intersection? So this is going to mean that X is in AI, right? For all I in the index set I. That's what this intersection mean. ऐसा ही है ना?
Yes, sir. ऐसा ही है.
कि भाई X A में है, R X is in AI for all I. अच्छा तो इसको मैं यूं भी तो लिख सकता हूँ ना कि if like okay like these are two separate statements but let's put them together. I say that X A में है या फिर X AI में है. No matter what I you take from the index set I. एक ही बात है. So just rewrote the same statement. And therefore, what does it mean? I can say that therefore X is in A union AI for all I in I. ठीक है? तो वही element X, the same element X is in A union AI, no matter what index you take from I actually. So therefore, this is precisely what is the definition of intersection of say I belongs to I, A union AI actually. ठीक है? इस intersection की बात हो रही है और X इसमें belong करता है. ठीक है? If X is in A union AI for all I, that means that X belongs to the intersection of A union AI. ठीक हो गया? And the converse is going to be for the reverse inclusion. For reverse inclusion, let's pick an X from what? This intersection I belongs to I or A union AI. ठीक है? So what does it mean? So if it is an intersection, it must be in all A union AI for all I in I. ठीक है? So this means that X is in AR, X is in AI for all I in I. ठीक है? So, you can argue in different manner. I can say that, okay, now, now there are two cases that can be, if X is in A, for example, X is in A or X is in AI. So if X is in A, so this must be in this union actually, right? इस union में जरूर होना चाहिए. अगर X A में है, so it follows that X must be in this union. And if the same X is in AI for all I, then it must be in the intersection and hence it must be in the union actually. Okay. So I can write this as, same thing, that X belongs to A or, इस statement का मतलब है कि X belongs to the intersection of I belongs to I and A. ठीक है? And if this is the case, this means that X is in A union intersection of I belongs to I and A. Okay. Hence, what does it shows? That this intersection of I belongs to I, A union AI is a subset of intersection of I belongs to I, not intersection, but A union. It is going to be A union intersection of I belongs to I, AI. Okay, and this is what it shows. And if the both inclusions are true, that means that this distributive law is true actually. Okay, this distributive law is true. So if you have any question, you may ask. Otherwise, I'm leaving the exercise for you to be solved actually. ठीक है? तो ये बाकियों को you have to deal with yourself. Now you can solve the most part of, especially those which are with the indexed questions actually. You can do the most part of the exercise 5.3 actually. You can do at least, I don't know, 1 to 9 problem based on it actually. Okay. So this is the stuff that is going to be really important if you are, when you are doing, what do you call this, the theoretical mathematics actually. So this stuff is really very important. Okay. So I think that's it from my side actually. So if you have questions, please do ask. Okay, will not start the new thing. I'm leaving a bit early today because it's useless to start a new topic now, because I know that you're not gonna get anything out of that new topic. So the best is that let's quit it here and try to solve the exercises from theorem 5.3, and this would be the last part of really the chapter 5 actually. Okay, so the chapter 5 is like over. I will not do the last section actually, which is on the axioms of set theory. Okay, it's really, it would be a deviation. So it's interesting, but it would be a deviation from the things that we would like to do actually. Okay, so in next class we will start with the we will start with the functions actually.